In this lecture, I will discuss how to analyze and design in detail steel frame building in ETABS 2016. So I will start from a scratch file, mean from a zero level file, new model. Okay, so here is a model initialization. These two settings I have discussed in the previous lectures. Now I will use built-in settings. And here is option for me. Either I want to use US customary system or metric SI or metric MK system. So I am using metric SI system. Okay, so here is steel section database. So here AISC SC14, that is FPS, means DW360, which is in millimeter. In FPS that will be W12. So if you want to use in the millimeter system, so here AISC 14M. So here is a steel design code. Different design codes are also available. I will select AISC 36010. Okay, that is a concrete frame design. So ACI 31814, so that's okay. For the detail, you can just go to I, that is the information icon here, that is a design code. Similarly here for the units. Okay, so I will start from a zero level, so that's why I will just click blank. Okay, okay, now the blank windows are appearing. Now I will click in the in the edit grid story data. Here is already 4 stories have been defined. I will click one more story. Okay, the previous heights are 3 meters, so I will just click above story 1. Okay, the ground story level is 3.5 meter. Okay, okay, so my 5th story is a master story, and the rest of this story are similar to master story. Okay, so when I will select story 5 and select from here similar stories, then all the rest of stories automatically selected. So that is the function of master story and similar to. Okay, so here is a grid modify. I can again select a quick rectangular grid system. So grids in the x direction, that is 4, in the y, that is 4. So here I am changing little bit. In the y, that is 5. Spacing in the x direction I am putting, that is 5 meter, and in the y direction that is a 6 meter. So x labeling A, y labeling 1 2 3 4. Okay, so here is a quick. So now I can again change the spacing one by one. For example, distance between B and C, that is I am putting 6 meter. So here similarly, if I want to put any value between 2 3, for example 3 and 4, so here I am putting 5 meter. So that's how you can draw the or define the grid system in ETABS. Okay, so now the grid system is appearing. I will click plan story 5 apply. Okay, so now I am at the level, top level, means at the 5th story. So now first of all I will define. Before defining, I will recommend please save the model. Okay, so steel frame design. Okay, the model has been saved. Now I will click define material properties. Here is a predefined steel material for the steel sections have been defined. That is a A992 FY50, that is a 345 megapascal. So let's see, modify. Okay, so that is a 345 megapascal steel. So now if you want to create a new steel material for steel sections, add new material, United States. So here there are two options, steel and rebar. Rebar is for reinforcement, steel are for this steel sections. so I have selected steel. So here if you want to use a 36 means 250 megapascal steel, you can select here. Okay, so here 250 megapascal steel. Okay, but I will use in this model 345 megapascal steel. Okay, so now I will go define section properties. I will click frame sections. In the defining of frame section properties, you can see here no W section is appearing. So for the W sections, I will click import new properties. Okay, here I will select steel I slash for white flange. Okay, okay. So now, so AISC again, you can select any database. I am selecting metric, and the material, that is a 345 megapascal. So from here I will select W3. So I am selecting 200 and above. Okay, 360 and 410 and even more 460. Okay, so these sections I have selected in the W category. Okay, then all the sections will appear in our find the property data. So now I will click add new property. Here that is a beauty function, that is a auto list function. Okay, I will click here. I will put composite beam. Okay, from here I will select, for example, for the composite beam I have selected in the category of W 250 by multiplied 32.7. okay, so all the W category I have selected. So in this auto selected option I have selected all the all the W sections that will come in the composite beam. Okay, I will explain later more what is composite beam and how it will behave. So now I will click add new property again, auto select list. Auto beam. Okay, okay, now I will define the steel column. Auto column. Okay, so okay, okay, now first of all I will draw the columns. Here draw column. Here I will select auto column. Okay, so here you can see a W section is appearing. Okay, so for example here when I click only one column will be drawn. I am doing Control Z, now selecting all stories. Okay, now you can see one column drawn in the all stories. Okay, okay, so you can also draw quickly. Okay, and I want to change the axis of these, or for example of these columns. Okay, so here I have selected these columns and go to assign frame section local axis. Okay, so if I want to change the major axis, okay, for example in this you can see. Okay, if I want to change the axis of this column, then there are two options. I will put here 90, or second way is, okay, change the major direction along the y-axis. Okay, apply. So here you can see, close. Here the major direction is x, here is the major direction in the y. Now first of all I will draw the primary beams, then the secondary beams. From here, okay, auto beam. So here when I click on the one, you can see all the beams will be drawn in the all the stories. So for quick, you can again, Control Z. Okay, okay, now the primary beams have been drawn. Sorry, one beam is left. Okay, so when I right click any beam, so here is the W250 by 115 auto beams is selected. In the auto beams there are many beams, okay, that is I have provided in the auto list. So when I will go in the design, if my section is going to fail, software automatically pick the higher section. Okay, so now I will draw the secondary beams. For the drawing of secondary beams, there are options available. For example, here, that is, secondary beams are parallel to the x direction. You can put number 3, number 4. So for example, if you want to do in the y-axis, here, okay, here I am drawing the secondary beams. I have selected all stories. Okay, now I am putting entering escape. So when I will right click any beam, here you can see the design will be as a steel frame design. Okay, but in the secondary beam I have defined the composite beam, but still here the steel frame design. So here escape. Now I will go in the define section properties in the deck section. In the deck section, default deck 1 is defined, modify. Here it's the deck properties. Oh. नहीं वो फिर नहाने की जरूरत नहीं की सिर्फ कपड़े बदलो जिससे पेशाब लगाओ धो लो बस और कोई जरूरत नहीं होती नहीं नहीं उसकी कोई जरूरत नहीं नहाने की जरूरत नहीं की हाँ वो सारा नहाना नहीं सिर्फ वही हिस्सा धो लो बस Here is a steel deck already defined. There are three unfilled deck. Okay. Second one is filled deck. All the values are HS. Okay. For example, HS, HR. Okay. TC, thickness of concrete, solid slab. Okay. All solid, not the deck. So here is the filled. Okay. So here is the TC value is 87.5. So here it is, I am changing it to 75 millimeter. So similarly you can put the values as per your requirement. Okay, the concrete material 4000 psi is selected for the steel sections, that is a 345 megapascal. Okay, now I will go in the draw. Okay, here I will select the deck slab. Okay, 1 point, second, third, okay, enter. Okay, so now you can see deck slab have been drawn on this building. I will go in the 3D. So one slab extra have been generated at the bottom. I will go in the plan, base, apply, OK, select only one story and click this slab, delete. OK, now again you can see no slab is present at the bottom. So when you design the base plate, so you have to consider whether it is a hinge base plate or a fixed base plate. So I am taking the boundary conditions, means the support condition, as a fixed condition, selected all these joint restraints as a fix, apply. Okay, so now I will apply the loads. So I want to show one thing more, apply. Okay, so here my edge column, edge beams, for example here you can see all the beams that will be designed as a steel frame design, and the secondary beams will be designed as a composite beam. Okay, when I will right click here you can see composite beam. First previously that is a simple ordinary beam. So when I provide the deck slab, then the secondary beams will act as a composite beams with concrete. Okay, so now I will go in the I will select all slabs, all stories. Okay, select. When I will click just one story slab, all story slabs will be selected. Here support condition are not looking fixed. I will just refresh the window. Okay, so now I will go in the assign, shell loads, uniform. Okay, in the dead. So first of all, I will define the load patterns. Okay, add new load, that will be super dead. Okay, now earthquake load in X direction, seismic. Okay, here I have selected ASC 710 code. Similarly in the Y direction. Okay, for the wind, in X direction. Similarly wind in Y direction. Okay, so now the slab is already have been selected. Now I will go slab have been already selected. Now I will go in the assign, shell loads, uniform. Okay, so here in the super dead I will apply 2 kilonewton per meter square. Okay, so you can also convert in the kg, just going in the units. Okay, you can convert into kg meter square and you can put in the value in kg. So for the super dead I have put 2 kilonewton per meter square. Now I will select again, apply live and apply 4 kilonewton per meter square, apply. Okay, you can check just by right clicking the slab. Okay, so here in the loads 4 kilonewton is a live, super dead is 2 kilonewton per meter square. Okay, so now I will define in the load pattern in the earthquake in the X direction, modify lateral load. I will select earthquake in the X direction plus eccentricity. Okay, that is a 5%. Program will automatically calculate the time period. Okay, the earthquake will be applied from base to story 5. Response modification, that is 8. Hour strength factor 3. You can put these values depending upon the structure type. Either is the intermediate, special moment resisting frame. You can put these values from the ASC 710 code. Okay, so here is the deflection amplification factor 5.5, occupancy importance 1. Okay, so here is a spectral acceleration, means short period acceleration, short period acceleration or 1 second acceleration. Okay, there are 3 different ways. Either you can put from the zip code of your country, or you can by putting the latitude longitude on the globe. You have software then automatically calculate the spectral acceleration. Short period means 0.2 second, 1 second spectral acceleration, software automatically pick, or you can put by user defined. Okay, so again that is long period transition, that will also come from the maps. So here I have selected the site class B. Okay, you can put as per your soil investigation. So if you don't know, then put F. Sorry, E. You can put E. If you don't know your class, put E. Then software will also automatically calculate the design, seismic design, spectral acceleration. Okay. Similarly, in the earthquake Y. Okay, rest of the parameters will be same. Here I will select E. Okay, so that's how we define the earthquake parameters as per ASE 710. Okay, now for the wind in the x direction, modify. Okay, there are 2 options. Exposure from extent of diaphragms means software automatically apply the wind pressure. So I will select the second option. I will apply myself. So by creating the cladding, include the shallow objects. So here is the wind speed, that is 85 miles per hour. So depending upon your location you can select. Again the exposure type, that is depending upon the terrain location. If your building is near to the sea, then the terrain location is different. If your building located in a congested area, then definitely its exposure type is different. Okay, again the wind will be applied from the base to top. Similarly in the Y. Okay, sorry, 80. Okay, okay, so now I will click 3D. Now I will draw auto cladding. So I will use the use the option floors. Software automatically draw the cladding. Okay, so cladding is basically the null areas, means these areas do not have mass and stiffness. So here when I click, sorry, that's not the here. Okay, now the cladding have been selected. Here in the assignment, okay, section property none, and see here this area mass again 0. Okay, so these will just act will distribute the wind loads to the frame structure. Okay, so now in the plan, okay, I will open A, grid A, elevation A, apply. I will select, then software automatically select areas in the all the areas in the elevation A of the cladding. I will go in the assign shell loads wind pressure coefficients. Okay, in the windward in the x direction. Okay, so I will put before putting I have to see the local axis, in which directions are the local axis. 3D. Okay, set display options. Okay, shell assignments, local axis, apply. Okay, so its direction is outward. Okay, so I have to apply the negative to apply the windward pressure in the x direction. Okay, now assign shell loads. Okay, uniform, sorry, assign shell loads wind pressure coefficients. Okay, windward is 0.8. Okay, so that the direction is outward, so I have to apply negative so that it will apply in the positive x direction. Apply. Okay, arrow is showing outward, but the negative value is towards the building in the x direction. So now I have to select this elevation. For that, first of all I have to draw the elevation. Sorry, close, draw. Okay, develop elevation definition. Here I am naming it elevation from right side. Okay, okay, now just enter. You will see the back side of the building. Okay, now I will just rotate, and here when I select, please see here, this portion is selected, this inner portion is also selected, this outsider portion is also selected. Okay, now I will go in the assign shell loads wind pressure. Okay, now for the leeward I will apply 0.5 because its positive direction is already outward. Apply. Okay, so that is in the x direction. Similarly, I will apply the wind load in the y direction. For that, again, see in the plan 5, I have to now see the elevation 1. Apply. Okay, again its third axis is outward. Okay, that is windward minus. Apply. Now I want to open the elevation 5. Okay, now the elevation 5 is open. Here all the cladding is selected. Now I will apply leeward and Z1.5. Okay, apply. Now the wind loads have been assigned. Okay, you are seeing the 0.8, the values are 0, but when we run the analysis, software automatically calculate the wind loads. So now we have defined the wind loads, earthquake loads, gravity loads. So now before analyzing, I want to check model. Okay, select all. Okay,